I can imagine at this juncture that you may have a question regarding the conceptual distinction between moderation and mediation. So I want to clear that up before we move on. So a mediation is depicted in the diagram at the top of this slide. And basically we have a causal model when we're talking about mediation. So we have a predictor variable x causing changes in a mediator, in this case, m, that middle box, and that in turn will causally impact our outcome. So an example of this that comes to mind is Aizen's 1991 theory of planned behavior that some of you may have heard of. And this is just the idea that we have attitudes toward a behavior, and that is our IV, and that is going to impact our intentions to perform the behavior, the mediator, and that mediator in turn, those intentions will drive the final behavior. So for example, if you have good attitudes, favorable attitudes toward running for fitness, let's say you believe that that is a good way to be fit, that will causally impact your intentions to perform that behavior. And then finally, those intentions will drive the probability or likelihood that you will go out and actually run periodically for fitness. Now, conversely, if you had fairly negative attitudes toward running, let's say you believe that it causes more injuries than it's worth, or that maybe you have attitudes toward running that say a little is okay, but a lot is probably not good for health. Okay, so that's a more sophisticated theory. It's a nonlinear, right, where we have no running as being unhealthy, lots and lots of running also being unhealthy, but at moderate levels it's good. That will also impact your intentions to perform the behavior. Specifically, you will intend to run twice a week rather than every day. And then ideally, those are in theory, those intentions will drive the behavior that you perform, the actual running and the frequency with which you will do so. So this is a mediation model. We are going to talk about these in the next couple of weeks. They are, I think, more complex to think about theoretically than moderations even are in some ways, because they involve causality, and when causality is in the picture, things are always more complex, as we will find out later. So the model below is a moderation model, as you can see. The relationship between x and y is impacted by a z variable or a moderator. And this is how moderations are always drawn, in this manner. You may have seen this before. X and y in this case may be a causal link, but it doesn't have to be. It just has to be a statistical association. So statistical association is different from causality, right? Because we can have things correlated that don't cause one another. So that a link between x and y may be causal, it may not be, but the link between x and z cannot be causal in a moderation framework. So if you believe that x and y have some kind of causal link with one another, then go for the mediation, because that's really what you are testing, is the one above, the model above instead. Okay, so no causal link there, and ideally, predictors, the x and the z in moderation, should not be statistically linked very, to a great degree, should we say, because then we have this multicollinearity thing where we can't parse out the interaction term from the main effects. Later we'll talk more about that. But having said that, I have seen moderations come out significant where there was a good correlation between x and z. Again, there wasn't a causal link, but there was a moderate statistical link, or maybe even a higher statistical link. So just know, though, that to the extent that those are correlated, it may be harder to detect the interaction effect, so you'll need a higher n size. Okay, so for now, I think that's a good enough explanation of the difference between these two, and later on in the course, this distinction hopefully will become much clearer.